in listen-only mode.
Hi, good morning and good afternoon, everyone. Thank you for joining us for today's webinar held by several nines and Woo servers in a joint session today. The topic is on how to build scalable database infrastructures with MariaDB and HAProxy. And we'll be looking more specifically at a business case on a company called CloudStats.me, which we will introduce to you over the next few minutes. My name is Jean-Jérôme, and I'm with the Several Nines team. I'll be your host for the next hour, and I'll be available to you in the question section or in the chat box as well if you have any questions on the system or on the presentation. During the whole hour, feel free to ask us questions in the question section, and we will answer those questions towards the end of the webinar. But feel free to ask them at any point in the question section of your control panel. This session is being recorded, and we will make the recording available to you in the next couple of days, so you'll be able to review the information at your own leisure. And just before I hand over to our first presenter, Andrei Vasiliev from Woo Servers, I just wanted to ask all of you who have joined us today a quick question before we get started. And this is just to understand what data stores you yourselves are currently using. So, of course, during the presentation, we're going to cover SQL and NoSQL data stores, as that was the setting also at CloudStats.me. And under SQL, we've listed here MySQL, MariaDB, Postgres, and under NoSQL, MongoDB and Elasticsearch, but you might be using others. If you have others and you would like to tell us about it, feel free to let us know in the question section as well. But thank you for participating in this poll for now. I'm just going to let this run for another few seconds, and then I'll share the results with everyone. Thanks very much. I'm just going to close this now and share the results. Great. So not too surprisingly, everybody today has a SQL data store. Well, so I assume so. Maybe it's a mix of MySQL, MariaDB, or Postgres. So that's nice to see. And then it's nice to also see a bit of a mix with MongoDB, NoSQL, and maybe you have some other NoSQL mixed in there as well. But this looks really interesting. Thank you for your participation in this poll. I think that'll help us understand a little bit who you are in the audience today. And with that, I'm going to hand over to Andrei for the first part of the presentation today.
Yes. Thank you, Jean-Jérôme. Welcome, everyone. My name is Andrei. I'm the CTO of Woo Servers. Probably some of you are customers. Some of you are users of CloudStats. If you haven't heard about Woo Servers or CloudStats, feel free to check them out. I'll be talking today about the database challenges that we had with CloudStats. I'll go through through several topics today. We'll have an overview of the CloudStats platform and the database challenges that we faced during its development. I'll show you the initial architecture that CloudStats had prior to the implementation of ClusterControl management panel. We'll discuss the scaling options that we've gone through and which we considered during the development of CloudStats, as well as load balancing options such as HAProxy and MaxScale. Then Art will show you the demo of ClusterControl database management panel, and then we'll go through the data structure that CloudStats currently has, and we'll show you the architecture that we came with during the implementation of ClusterControl. We'll go through the benchmarks that we performed on various cloud storages, which allowed us to choose the correct storage for a high-scale application like CloudStats. And also we'll go through the outcomes of this webinar. So let's begin. Just for you to understand what CloudStats is, it's a website and server monitoring platform. It was initially developed as an internal project for Woo servers monitor their client servers inside the company. It was one of the monitoring servers we employed, but it was never meant to go public first. And only after a lot of testing and a lot of development in July 2015, we launched the version 2, which went public and which allowed any user to join and anyone to use CloudStats as a server monitoring platform. And the number of servers began growing rapidly, and by February 2016, it reached 2,200 servers and 1,500 websites monitored every single minute. So right now, the data that we are receiving is quite high. We're getting a lot of website agent updates because every server and is meant to install the agent on their server, and the agent sends an update every minute to CloudStats platform, which gets recorded into the database. And as the number of monitored servers grew, the load on the database increased steadily as well. And now we're having around 2,200 server agent updates per minute, 1,500 website status checks per minute. Then we also ping every single server, and we have IP monitor checks. Furthermore, of course, we have visitor traffic, which opens dashboards, which go to ping maps, etc. So right now, the database is having up to 2,000 database connections per second, and we're collecting about 15 to 20 gigabytes of data, which amounts to around 450 per month gigabyte, and around 5.6 terabyte per year. So this is quite a large amount of data. And actually, before the reason that the growth has been restrained is because we wanted to make sure that the database is capable of handling 10,000, 20, 50,000 servers monitored. Because if the platform becomes really popular tomorrow, and we're working on this, we need to make sure that the infrastructure is ready and everything is prepared for booming viral growth. So we're actually restricting the growth to make sure that everything is in place to be able to support a large number of users. So the architecture in the first place was quite simple. We had a few application servers, which are shown on the diagram, and we had a master-slave MySQL replication set up. And this was enough actually before the second version went live, and this was enough for the internal monitoring of our servers. But unfortunately, with the version 2, we recognized the problem that MySQL master was going down frequently, and we started having database issues due to high load. And we found out that it was requiring scaling. So such setup is probably the most standard setup in many organizations, where you have a master and you have a lot of slaves. Another issue that we experienced is that we had a lot of write requests to the database, because usually databases have a lot of read requests, and in our case we were collecting data. So we had a lot of write requests, and it's very difficult to scale master-slave replications for a lot of write requests instead of reads. So this was not actually the solution that would allow us to successfully grow the application. So also it had no graphic interface, master was crashing, and we kept having replication issues. So once the traffic went really high, we started looking for other solutions. And we considered a lot of options which you are probably aware of. Partitioning is the most standard way of splitting data based on range, list, hash, or key. It allows you to store large amount of data on your servers, distributed by date, for example, where you place today's data into one partition, yesterday's data into another partition, and this helps to reduce the load on the database, but you don't really fix the problem of scaling. So other types of scaling are sharding and auto-sharding, allowed by MySQL Fabric or MySQL Cluster. But the problem with those, the main problem of those is that you distribute your data across several nodes, and the data is stored by, for example, user ID. So you're hosting user ID to 100 on one server, 100 to 200 on another server, and your application needs to know where to go to pick the correct data. So there must be some application logic present in your app to be able to pick up the right data from the correct database, and the management may be quite a lot manual. It will require a lot of manual work, manual configuration. So there are a lot of things that can go wrong in sharding. So this was not actually the solution that we chose. The master-slave replication, as I mentioned, also has a lot of drawbacks, such as topology changes, managing slave lag, promoting slaves, repairing replication issues, fixing broken nodes, managing schema changes, and scheduling backups. So we actually chose the Galera cluster with the ClusterControl management panel because it allowed us to have a master-master replication, and we were able to scale the large number of writes to the database. And the load balancing options that are currently present in ClusterControl and elsewhere. There are two main ones. The first one is HAProxy, as you probably know. It's actually quite less resource intensive than MaxScale. MaxScale is a new product developed by MariaDB, so it's meant to work best with the MariaDB database. But HAProxy is an open source load balancer, and it's very easy to set up, and it has a graphic user interface. And however, MaxScale offers you intelligent routing. In that case, it offers you the read-write split, and in this case, you can, for example, send write requests to one database server and send read requests to 10 other servers. And this way you can scale reads and writes and intelligently route the queries to the correct server. We chose the HAProxy for our setup because MaxScale is a new product. It's still being developed, and we actually tested it. But we found that HAProxy was easier to use, had a graphic interface that allowed to monitor the number of connections, the number of sessions that each of the database servers was receiving. So it will depend on your setup, which load balancer you will consider. MaxScale is a new product. It will offer you a read-write split, but HAProxy is very easy to set up, and it's kind of bulletproof, run by lots and lots of companies out there. So it's really for you to test in your environment what will work best for you. For us, it was HAProxy this time. Now Art from Several Nines will show you the ClusterControl